This is 5.1, Solving Systems of Linear Equations by Graphing, Part 2. The solution of a system of linear equations is the point on the graphs. It's the point of intersection. Point of intersection of the graphs of the equations. So to solve a system of linear equations by graphing, we have a few steps to follow. First one is to graph the equation, both of them, on the same coordinate plane. If I graph them separately, I cannot find where they intersect. Step 2 is to estimate the point of intersection. You say, it looks like they're crossing at the point 2, 7. So you would then take that point and check it by plugging it in for x and y into each original equation, just like we did in Part 1. So, let's solve the system of linear equations by graphing. First, I'm going to graph equation 1 and equation 2 on the same coordinate plane. So doing that, this is in slope-intercept form, where -1 is my y-intercept. So I plot my y-intercept. That's where it crosses my y-axis at -1. Then my slope is 2. So that means I go up 2 to the right 1, up 2 to the right 1, and put my points. Or I could go down 2 to the left 1, down 2 to the left 1. Same idea for equation number 2, except this one does not give a y-intercept. There's no plus or minus with a number. So we know that we would have a plus 0, so the y-intercept is 0. Then from there, my slope is 3, so I go up 3 to the right 1, or down 3 to the left 1, and plot my points. Now, step 2 says to estimate the point of intersection. And I can see they intersect here, and it looks like they're at -1, -3. Your points are always listed as your x first, then your y. So it looks like it's -1, -3. So I'm going to check it by plugging it into each equation to make sure that I am accurate and I did my graph correctly. So plugging it in, we have -3 equals 2 times -1 minus 1, and that simplifies to -3 equals -3, which is true. Plugging it into equation 2, -3 equals 3 times -1, which is -3 equals -3. So, -1, -3 is the solution. It is the point where they cross. Another example, if I have these two equations, y equals 2x plus 1, and x plus 2y equals 8. This one is a little different because not each equation is written in slope-intercept form. That means we have to take this second equation. It's written in standard form, which is x plus y equals a number. So we're going to change it around and make sure that they are both in slope-intercept form, because that's the easiest way to graph from it. I could graph from standard form, but that's choosing x's and y's and making a table of points. So when I solve for y and get it in slope-intercept form, my equation is now y equals -1/2 x plus 4. And I know this 4 is my y-intercept, and I have a slope of -1/2. So when I graph these, I have my y-intercept of 1 and a slope of -2. So I go down 2 to the right 1, down 2 to the right 1, or from my point I can go up 2 to the left, up 2 to the left. And for graphing my second equation, my y-intercept is 4 with a slope of -1/2. So I go down 1 to the right 2, down 1 to the right 2, up 1 to the left 2. And it looks like they cross at the point -2, 5. So plugging those in to each equation, I can see that this is a solution to the system. I also have two more equations that you can graph, and in doing that, they are both written in slope-intercept form. And so you are going to take your y-intercept and for each one, plot them. And when you do that, you're going to see that you get two parallel lines. This is because they have the same slope, but different y-intercepts. And we know that parallel lines do not intersect. They will have no solution. So parallel lines will always have the answer of no solutions. You have a total of 18 math and science exercises for homework. You have 6 more math problems than science problems. How many exercises do you have in each subject? So, in word problems, it's important to take out all of the important information. So, I'm going to take out, I have a total of 18 math and science. So that means if I add math and science together, they will equal 18. Then it says I have 6 more math problems than science problems. So x equals, so number of math is 6 more than science. Now to graph these, I need to make sure that they are both in slope-intercept form, because that's the easiest way to go. In doing that, my 18 equals x plus y is going to be y equals negative x plus 18. And in solving equation 2 for y, I get y equals x minus 6. So I have my y-intercepts of 18 and a slope of negative 1. So it crosses my y-axis at 18. And I go down 1 to the right 1. Or in this case, each scale is worth 2, so I go down 2 to the right 2 and graph my line. For equation 2, I have a y-intercept of negative 6. So we'll cross my y-axis down here, and I have a slope of positive 1. So I go up 1 to the right 1, up 1 to the right 1. And it looks like they cross at the point 12, 6. So I'm going to take that and plug it into each equation, and I see that it is true. So this means I have 12 math problems and 6 science problems.